The James Webb Telescope discovery before the Big Bang changes everything. What is the universe's starting point? How did things seem before the Big Bang? Do we inhabit this enormous world alone? These are just a few of the numerous questions that have kept some scientists up at night for years. No technology could show us anything about our existence and creation, so they devised many programs and missions to learn as much as possible. It took decades for scientists to construct the James Webb Space Telescope, a massive telescope that's supposed to help us understand it. The question is, however, how this universe was made. Can this James Webb Space Telescope accomplish that? The James Webb Space Telescope, or JWST, has started its mission to capture images of the creation of the universe after a tense launch on Christmas Day. The $10 billion James Webb Space Telescope will study the cosmos to understand the universe's history, from the Big Bang to the emergence of extraterrestrial planets and beyond. It is one of NASA's most impressive observatories of large space instruments, such as the Hubble Space Telescope, which can see far into space. To observe the dim infrared light from the first galaxies, James Webb Space Telescope will travel back in time more than 13.5 billion years. This will shed light on a previously unobserved phase of cosmic history that helped to create the universe as we know it today. NASA claims that JWST is intended to observe a time in the history of the universe that has not yet been observed, rather than the universe's origins. The question at hand is whether James Webb will be able to carry out these tasks, or how it will be able to see through thousands of light years. The James Webb Space Telescope is a cosmic time machine that can see galaxies and stars as recently as 100 million years after the Big Bang, the universe's unfathomably destructive beginning. Webb will have much greater sensitivity and be able to observe light at longer wavelengths than Hubble. According to NASA, Webb can observe the first galaxies to form in the early universe because of the longer wavelengths. The telescope is so powerful, according to John Mather, the mission's lead project scientist at NASA's Goddard Space Flight Center in Maryland, that you could see it with your unaided eye from 240,000 miles away, the distance between Earth and the Moon, if you were a bumblebee. We'll be able to figure out how this is even possible. The JWST's 4 scientific instruments can observe the visible, near-infrared, and mid-infrared wavelength ranges. Electromagnetic radiation, having wavelengths shorter than radio waves but longer than visible light, is known as infrared light. Paul Geithner, NASA's Goddard Space Flight Center's Deputy Technical Project Manager for the James Webb Space Telescope, has various reasons for investigating infrared. One explanation is that the ultraviolet and visible light that the universe's initial bright objects produced when it was still very young has been stretched by cosmic expansion and is now, approximately 13 billion years later, reaching us as infrared light. Webb will be keeping an eye out for the first light. Another idea is that the gas and dust clouds in which stars and planets developed are what obstruct our view. Because infrared light can pass through these clouds, we can see inside them. We don't know how the universe changed from a simpler state of hydrogen and helium to the one we see today. Still, the Webb telescope will give us a peek into the far reaches of space in a manner never previously possible, helping us find the answers to these essential questions. After performing low-resolution spectroscopy and mid-infrared photometry at high-resolution near-infrared, Webb will conduct ultra-deep near-infrared surveys of the cosmos to discover the first galaxies. The investigation of reionization will involve the use of spectroscopy. This would allow the James Webb Space Telescope to see previously unseen phenomena, ultimately aiding in the discovery of human existence. With the help of this superb telescope, we're going to examine all that we can see in the universe. We want to know how we got to the Big Bang, he continued. How did that function? So we'll search. We have concepts, we have forecasted. However, we are baffled about how to find the answers. First light and reionization, galaxy assembly, the formation of stars and protoplanetary systems, planet formation, and the origin of life are the 4 subtopics of the James Webb Space Telescope science mission. First light describes the early universe after the Big Bang, when the universe as we know it began. The early universe was a sea of particles, and the light was not visible until the universe had cooled down enough for these particles to start mixing. James Webb Space Telescope will also investigate what took place during the epoch of reionization, which is the time following the formation of the first stars and the accumulation of gases in spiral galaxies. One of JWST's aims is to examine the oldest galaxies' evolution to better understand how the galaxies we see now developed over billions of years from various shapes. Additionally, scientists are trying to understand how the current diversity of visible galaxies came to be and the existing mechanisms by which galaxies form and come together. Due to Webb's exceptional infrared sensitivity, astronomers can compare today's grand spiral and elliptical galaxies with the weakest early galaxies. This will facilitate astronomers' understanding of how galaxies form over billions of years. The pillars of creation in the Eagle Nebula are some of the most well-known places where stars are produced. Stars develop in gas clouds, and the radiation pressure they exert blasts the surrounding gas away as they grow more significant. However, it isn't easy to see inside the gas. The JWST's infrared eyes can detect heat sources, like stars forming in these cocoons. Still, the most significant finding is that many exoplanets have been found in the past 10 years, particularly with NASA's planet-hunting Kepler Space Observatory. JWST's robust sensors will also be able to examine these planets more closely and image their atmospheres. In some situations, knowledge of a planet's atmosphere and its conditions during creation should assist scientists in predicting whether or not a world is livable. According to NASA's deputy administrator, this is a once-in-a-lifetime opportunity. This has been thrilling for centuries as NASA keeps expanding the realm of possibilities. The grand puzzles of the cosmos' origin and the existence of life elsewhere in the universe has long fascinated people as they gaze up at the sky. Webb will remove the blinders and demonstrate how the universe came into being. According to Melroy, the public good for science and exploration for which our space program was formed is represented by this telescope. Using the transit approach, which includes watching starlight fade as the exoplanet passes in front of the star, Webb will search for extraterrestrial planets. The radial velocity method, which gauges the star wobble brought on by the planet's gravitational pull, will be used to calculate the planet's mass. The planet's atmosphere will subsequently be spectroscopically examined by Webb using chronograph telescopes, which observe a star's corona and enable direct imaging of exoplanets circling nearby bright stars. An exoplanet will only appear as a spot in the photograph. By identifying and characterizing comets and other ice objects in the solar system beyond Earth, scientists can learn a great deal about exoplanets, including their color changes between winter and summer vegetation cycles and weather. Comets and Kuiper Belt objects could reveal our planet's origins. Webb will make some scientific investigations into our solar system possible. The telescope's sensitivity and near and mid-infrared spectral coverage will help NASA's other solar system missions. James Webb Space Telescope will be a masterpiece if all goes as planned. There's nothing like it that has ever been made. The idea is that James Webb would not only revolutionize astronomy, but also give us hope that we can discover where we came from.